Area of irregular polygons worksheet. Under a bit of a time constraint, so I'll do as many of these as I can, as quickly as I can. Remember tomorrow this is on sections 10.4 and 10.5, and 10.5 actually dealt with the trig ratios. So if you want on any particular problem to use special right triangles, that certainly will be okay, but you are welcome to use the trig ratios on all of these problems, even if you might think that they are easier with the special right triangles. Okay, area of regular polygons, the first one starts out actually pretty easy. Remember the formula is the area is equal to 1/2 the length of the apothem times the perimeter. And in this first problem, we'll see that we're actually given the apothem, so 1/2 the apothem for √3/3 times the perimeter. The perimeter is equal to the number of sides times the length of a side. In this case, that is 24. So you can actually just find the value of that for √3 divided by 3. And that's 2.3. So 2.3 times 24. And you will get that it is approximately 27.6 units squared. Remember, you don't have to use simplest radical form on this test. Number 2, again, you are given the apothem and the length of a side. So the area is equal to 1/2 the apothem times the perimeter. 1/2 in this case, the apothem is 14.4. Again, the perimeter is equal to the number of sides, 1, 2, 3, 4, 5, 6, 7, times the length of a side, 13.9. So 7 times 13.9 would be 97.3. So the perimeter here is 97.3. So 1/2 of 14.4 times 97.3 should be approximately 756. We said we're going to round to the nearest tenth, so let's round that to a 6. Number 3, again, you're given the apothem and you're given the length of a side. So the area is equal to 1/2 the apothem times the perimeter. So 1/2, 14.5 times the perimeter, and this is 1, 2, 3, 4, 5, 6, 7, 8. 8 sides times the length of each side, which is 12. So we have 1/2 of 14.5 times 8 times 12, which is 696. And again, that's units squared. Number 4 doesn't look quite like it finished the picture, so I'll just finish it. It is a regular pentagon, and the apothem on that was 5.1. And the length of a side is 7.5. So the area is equal to 1/2 the apothem times the perimeter. So 1/2, 5.1 times the perimeter, 5 sides times the length of each side, 7.5. So that equals 95.6. Number 5, that's another one. All of these are actually fairly easy. A lot of the information is already provided. You're just using the formula. So 1/2 the apothem, 16.5 times the perimeter. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides times 12, and that gives us 0.5 times 16.5. 891 units squared, or number 5. Number 6, again, I have the apothem, I have the length of a side. This is a hexagon, so the area is equal to 1/2 the apothem, 5 root 3 times the number of sides times the length of each side, which is 10. Again, you can get that 5 root 3 in decimal form, and that would be 8.7 times 6 times 10, which will give you an area of approximately 259.8 units squared. Number 7 says you have a regular pentagon with an apothem of 7.3 and a side of 10.6. So the area is equal to 1/2 the apothem, 7.3, times the perimeter. The perimeter would be the number of sides, 5, times the length of a side, 10.6. That should give you an area of approximately 193.45 units squared. Number 8 is a triangle. So you're going to use the area is equal to 1/2. The apothem is 14. The length of a side is 28 root 3, and there are 3 sides. So 3 times 28 root 3. Remember, you can convert that 28 square root of 3 to a decimal. So in this case, it would be 1/2 times 14 times 3 times 48.5. And that's approximately 1,018.4 units squared. Now let's go to the problems on the back. They're a little harder. I'm actually going to skip 9 and 10 because they're very much the same. You're given the side and the apothem, and you just need to use the formula. When we get to number 11, now is when you're going to use the trig ratios. Again, if you wish to use special right triangles, you certainly may, but you also can use the trig ratios on any of these problems. The formula is still the same. The area is equal to 1/2 the apothem times the perimeter. However, now I'm not given the information directly, and I must find it. So I know this central angle measure is 360 divided by the number of sides, which is 120. I will bisect that central angle with the apothem, which will be perpendicular to the side, and I divide that central angle, which is 60. I'm going to be looking for A, the apothem. X is half the side, so S is equal to 2S. Now I'm going to go ahead and use sine, cosine, and tangent. So for the first one, I want to find the apothem. So I'm going to take cosine of 60 is equal to A over the hypotenuse, which is 18. The variable's up high, so you multiply 18 times cosine of 60 equals A. So A is equal to 9. Then I need to find the length of the side. So I'm going to take the sine of 60 is equal to x over 18. Again, the variable's up high, so you multiply 18 times sine of 60 equals x. And that is x is equal to 15.6. Remember, though, the length of the side is 2x. So the length of the side, S, is actually 31.2. There are 3 sides, so we have to take the length of the side, multiply that by 3 to get the perimeter of 93.6. And now we'll just use the formula. So the area is equal to 1/2 the apothem, 9, times the perimeter, 93.6. That should give us a value of approximately 421.2 units squared. Excuse me. Number 12 looks like it didn't completely end up on the picture, so I'm going to skip to, look, didn't take very many pictures very efficiently. So let's go back to 12 and try to finish this. It's not working well at all. Okay, so on number 12, you were given the length of the apothem. Is 4 square root of 3. Again, we're going to use the formula. The area is equal to 1/2 the apothem times the perimeter. This is a regular hexagon. You could use special right triangles, but we wanted to emphasize using the trig ratios on this worksheet, so we're just going to do the trig ratios. So we find the central angle measure. Remember, that's 360 divided by the number of sides gives us that central angle measure. Then when we bisect that central angle with the apothem, the length of the apothem is 4 root 3. In order to find the length of the side x, we're going to use the tangent ratio. So tangent of 30 is equal to x over 4 root 3. Again, you can find a value of 4 root 3 in your calculator. So you would have tangent of 30 is equal to x over 6.9. Variable's up high, so you multiply 6.9 times tangent of 30 equals x. So x is equal to 3.98. We're going to round that to 4. Remember, the length of a side is twice the length of x, so a side is equal to 8. So now the area is equal to 1/2 the apothem, 6.9, times the perimeter, 6 times 8. So the area for number 12 is about 165.6 units squared. Okay, number 13. Now this is a prime example of an equilateral triangle in which I have the length of a side, and the formula area is equal to 1/2 b times c times sine of a is the easiest and probably most appropriate for this problem. So the area for this is equal to 1/2 10 times 10 times sine of 60. And you can just multiply all of that together. And times 10 times sine of 60 should be, it's about 43.3 units squared. Don't forget this formula. It's very useful when you have the lengths of 2 legs and the included angle, and you will have problems like that on the test. Number 14, actually we'll try finishing this off. I don't think that's what it looks like. Okay, so I think this is a hexagon. Very sorry looking hexagon at this point. So remember again, this is one of those problems where this is a hexagon. You know this radii is also 8, this central angle 60. You can find the area of one of those triangles by using 1/2 b times c times sine of a. So in that case you would have 27.7 is the area of one triangle. There are 6 congruent triangles in a regular hexagon, so the area then of the hexagon is equal to 27.7 times 165.6, which should be approximately 165.6. Number 15, you have a quadrilateral with a radius of 16.5, or 16 square root of 2. If it's a regular quadrilateral, that means it's a square. So that means the radius is 16 root 2. This would be a 45, 45, 90. That's the hypotenuse of that little triangle. Therefore, the leg would be 16. This is probably the easiest way to do this problem. If this leg is 16, that means this leg is 16. That's half of the side, which is 16. So our square is 32 by 32. So the area is equal to 32 squared for this problem, which is 1,024. Number 16, I have a hexagon with side length of 16 root 3 over 3. Again, you can convert that to a decimal. So that is approximately equal to 9.2. So if you have a regular hexagon, remember there are several ways you can do this problem. If it's a regular hexagon, you know that each of those congruent triangles, and there are 6 of them, you know that the side is 9.2 because they're all congruent sides. This side is 9.2. So the area for this is equal to 1/2 B times C times sine of A. And if you calculate that, you should get approximately 220.2. And unfortunately, that's all I have time for. So good luck tomorrow on the test.